Okay, our final page. Let's get it done. Here we are. Okay, so we flip the page and oh no, the dreaded word problem. Oh my goodness, we call this angle of elevation and depression. That we've got some skier coming down and they're saying we've got an angle of depression. So the ski run is 1,000 yards long and it drops 208 yards over that span. And they want to know what is that angle of depression. So how much down off of horizontal is that? But one thing we want to remember is that the angle that the skier looks down would be the same thing as an observer looking up at the skier. Those are alternate interior angles. So I'm looking for the angle. So remember, we're going to have to hit that second button or that inverse button, depending on the calculator that we have. So I notice this is opposite and hypotenuse. So I'm going to write the whole thing down, but I can see it's got to be this guy. So I know that the sine of the angle, and I personally like to use theta, the Greek letter theta, sine is 208 over 1,000. And that's all I really need to do is I need to hit that second button with a sine, and it was a sine because it was opposite over hypotenuse. It's a second because I'm looking for the angle. And I just put in the ratio, and I say, hey, calculator, I got a ratio of 208 over 1,000. Could you tell me that angle? And it says, hey, you got a 12-degree slope. 12, let's see, it doesn't really say how to round this, so I'll go 12.005 degrees. Cool. Now, in number 20, it's a little bit different because they said from this this tower, somebody looks down at 19 degrees. That's kind of funny. They observed this airplane. Oh, I guess I thought that was flying. I thought that was weird, but it's down on the runway. But we know that if the tower looks down at the plane on the runway at 19, then the plane could look up at the tower at 19 also. And again, SOHCAHTOA, you should know that this is a TOA. That's an opposite over adjacent. So I would say then that the tangent of 19 degrees is opposite, which is 129. 120. That looked like a 9. That's a 120-foot tower over some unknown value x. Now, this will work perfectly fine. We're going to cross multiply and therefore divide. But I like a different way better. I'm going to take 120 divided by the tangent of 19, and I got that x has to be 348.505. Again, it doesn't say how much to round this, but like I said, I have a slightly different way, this is feet, that I like to do that. Because I know that if this is a right triangle and that angle right there is 19, if I start with 180 for the triangle and I take away the 19 that I have and the 90 that I have right here, I know that this angle up at the top is 71. So as it turns out, if instead of looking at this angle, we looked at this angle, I could say that the tangent of 71 is opposite, which is the question mark over 120. And I personally like that a little bit better because if I cross multiply, 100 times the tangent of 71 gives me exactly the same answer as I got before. I just like that answer a little bit better because I had the variable on top instead of the bottom. And blessedly, we were right down to the very last two questions. I like these a lot because these are special right triangles, and I know that I can always do those very quickly. I know that this angle over here is this side is 4 roots of 3. So remember, if you take the hypotenuse of the triangle, because that's that little triangle right there, I should cut it in half to get the short side. So that short side should be 2 roots of 3. And, oh, so that's kind of funny. It says, oh, A, and then we want B and C. Okay, so that's 2 roots of 3, which means this side would be 2 roots of 3 times root 3, because remember, here to here is times root 3, but root 3 times root 3 is 3, so this makes it 6. So now if we switch, and instead of looking at the little triangle, I look at this kind of medium-sized triangle, that short side of that triangle is 6, which makes its hypotenuse 12, and it makes this side right here, the short side times root 3, so that's 6 roots of 3. So what I have is all of the triangle sets, because I could use a 30, 60, 90 here, and then I could use another one here. And so I know the value of B is just 12 because it was double this 6. And since this one is 6 roots of 3 and that one is 2 roots of 3, then the entire thing is 6 plus 2 or 8 roots of 3. That's kind of fun. And by the way, you'll notice that if you look at this right here, this triangle, 4 roots of 3 is the short one. The long one is twice as big, which is 8 roots of 3. What do you know? That actually worked too, because the whole thing was a big 30, 60, 90. And so we'll just play one more time with that idea that if this little guy right here is 3 roots of 3, right there, 3 roots of 3, then I'm looking at this 30, 60, 90 right here, making this guy twice as big. So this would be 6 roots of 3. And if this is 3 roots of 3, then to get to this medium length side, I would take 3 roots of 3 and I would multiply by 3. Then I get 3 times 3 or 9. Now, as it turns out, I didn't ask you to go any further, but we really honestly could, because if I know that that is 9, then I know that this side is 18. And if I know that this is 6 roots of 3, then this whole thing right here would be 12 roots of 3. So we could keep going if we wanted to. We were not asked to do so, but sometimes it's kind of nice to see how these problems can kind of work their way around. Notice if that's 9, then this guy would be 9 roots of 3. And 9 plus 3 is 12, so 12 roots of 3 kind of makes sense. All right, well, there you go. We are done with the review. Hey, hopefully that wasn't too painful. We'll see you back in class. Goodbye.